Hi, huggers. I am here to bring you Learning Target 2.4 Population Dynamics. But what that really means is I'm going to be talking about the factors and the indicators that you would use to determine population change over time, so population growth or decline. Okay, so learning objective is that big bullet point at the top, explain the factors that account for contemporary and historical trends in population growth and decline. There's a lot of vocab associated with this learning target. So if you haven't already read your AMSCO book and identified some of those terms, you're going to see on the next slide. I'm not going to talk to you or give you the definitions of what these indicators are, but you really need to make sure that you have them. And if you haven't read your book yet, you might want to do the reading before you continue through this presentation. I think it will help you. Okay, so there are three primary factors that influence population growth and decline. Mortality, which is a measure of the number of deaths in a given population over time, fertility, and migration. Now, if you're looking under those terms, mortality can be as simple as looking at like how many people in a population die. It doesn't really differentiate between like younger people, middle-aged people, older people. That would be your crude death rates. And I have in parentheses there, crude death rates are not a good indicator for development. I'm going to talk about that just in a minute, but the other ones really are. So you can look at infant mortality rates, you can look at child mortality rates, maternal mortality rates. All of those, if they are high, indicate that the country is less developed. Life expectancy, I know it's kind of the exact opposite of mortality, but when you see high life expectancy, you would imagine that the other factors above infant mortality, child, and maternal mortality rates tend to be lower. So high life expectancy typically means you're looking at a developed country. But again, crude death rates, though a very important indicator when we're talking about population growth and decline, it is not a good indicator for development, and I'll show you why on a map slide later. Fertility is the same thing. You can look at total fertility rate, which is the number of babies that are born to any woman during her like fertile years. Or you can look at crude birth rate, just the number of babies that are being born out of 1,000. Natural increase rate is the one that we're going to look at and rely on a lot over the course of this unit because it takes into consideration birth rate and death rate, which you'll see on the next slide. And then just a nod to population pyramids when we're talking about total fertility rates. Don't forget that you guys have already learned a little bit about this when we were looking at population pyramids because replacement rate, that 2.1 in terms of total fertility is what gives you that nice rectangular pyramid, which is a stable population growth, which is what most countries actually are trying to achieve. And then, of course, the third factor is migration, which is the second part of this unit. So let's just talk about how demographers really do measure population growth. What you're seeing on the screen right here, rate of natural increase, this is, hug. It's not like you guys have so many terms to memorize that like College Board just likes to make it even more complicated by giving you two names for the same term. So sometimes you'll see this referred to as rate of natural increase. Other times you'll see it referred to as natural increase rate. In either case, what you're measuring is population growth, obviously. So the way in which you determine the rate of natural increase, is by taking the crude birth rate and subtracting it by the crude death rate and dividing it by 10. So that gives you an average of how fast the population is growing. What it does not figure in is migration. So if you want to account for like the total population growth and or decline, then you'd probably want to use the demographic equation, which is RNI and IR added to the net migration, which is how many people came in versus how many people left, or minus how many people left. Now, here's something to consider about the term natural increase rate. It's a little bit misleading because of the term, like the word increase. R and I can be negative, which if it is negative, if you're getting that negative number, all that means is that your population is not growing at all. It's just in decline. So just be aware of that as you're doing calculations to determine this. Okay, another way that demographers are looking at how to measure population growth is by looking at population doubling time. And so in order to like just you are going to read about this but a little bit later. So population doubling time is just what it says there. It's just time that it takes for any given population to double. So the more time it takes for a population to double, the slower the population is growing. And the opposite is true too. So for the longer it takes, the faster, let me try that again. The faster amount of time it takes for a population to double, the faster the population is growing. I think I said that right. If I didn't, I think you guys get the gist. So on the screen right here, you're seeing in year one, which is just like humanity, year one, the estimated population was about 250 million people that were living on the planet. It took 1,650 years, or till the date 1650, for the population to double, and so that's where you're seeing the doubling time. So that's how much time it took. Go back. And then for the population to double again, look at the difference. So it's like 1,600 years, 200 years, 120 years, 50 years. So you can see that the population is exponentially growing. It's not arithmetically growing. So that's all population doubling time is. And there is this really weird calculation. It's called the rule of 70 in order to determine how fast or slow a population is going to double. You just take 70, divide by the NIR, RNI, and that will give you doubling time. I don't know why this equation is like how it works. I just know that it does. So somebody way smarter than me figured out that 70 was a magic number to figure out population doubling. Okay, let's look at some maps and then we'll look at some consequences. So regarding this map right here, what you are looking at is population growth. And this should come as no surprise. Like students usually pick up on this pretty quick. Like if the number is good, it's probably happening in a developed country or a core country. If the number of the indicator that you're looking at is bad, probably happening in a least developed country or a periphery country, and potentially even semi-periphery country. But it's really interesting when you're looking at population growth. There are exceptions to the rule, and we'll talk about that when we talk about crude death rate in just a minute. But even there are exceptions when you change scale and you look like subnationally. So if you look at um, if you look at our country, you can see that this area over here, that Nevada is actually growing in population. And some of the other regions of the United States too are growing in population, where other parts of the United States are actually decreasing. So scale is actually important here as well. But by and large, most of the population growth that is occurring in our world today is happening in sub-Saharan Africa, which is this region. And most of the places where our population is in decline is in Eastern Europe or Japan. New evidence is suggesting that China's in a little bit of trouble, Singapore is in a little bit of trouble. And by trouble, you'll understand what I mean later. Because you don't like negative population growth is not good for a country either. So super fast population growth is not good. Negative population growth is not good. And we're going to explore the consequences later. This is all about causes. So that's all I'm talking about for this presentation. Okay, here's another map, so you can see that there's some overlap between these two maps. And I'll kind of go back and forth too. So like if we go back, oops, what has happened? Let me see. Lost, there we go. Okay, I'm trying to figure out. Okay, there we go. So you've got population growth and you have child per childbearing year, so total fertility rate. It is, I guess I should maybe stop talking and let you see if there's any overlap between these two, right? So is there overlap between where the population is growing the fastest and total fertility rate? The answer is, of course, yes. Now, here's something that I want, so just to give you like an idea of total fertility rate in the world, right? Replacement rate is 2.1. That's your like stable population growth. The world as a whole is growing at about 2.5 children per woman. In Africa, it's more than 5. And in most of Europe, it's less than 2 or less. And the thing that I want to make sure that you guys understand when we're talking about the total fertility rates and so on and so forth is that when you're looking at these percentages, these growth rates, like population growth is compounded. So when you see like a difference, say between like a 2% growth rate or a 3% growth rate, like make sure that you are understanding that that percentage actually makes a huge difference. So if a country grows by 3%, then it grows again by 3%, you have to remember that it is including that second year is including the rates from the first year, right? So then if it grows by 3% again, or maybe even 3.1%, you're just going to see an exponential growth in population. So again, just worth a quick mention. And then this is crude birth rate. And again, I just want you guys to kind of see total fertility rate, crude birth rate. There's a significant correlation between these three pieces of data. So where one is high, the other is high, all three are high, and so on and so forth. Okay. All right. So, and crude death rates. Oh yeah, before I move on, this was the map that I was wanting to show you. I kind of like lost my train of thought for a minute. So when you look at crude death rates, one of the things that I need you to understand is that in countries with high life expectancies, which are the most developed countries, you are also going to have a high crude death rate. Why, you might ask? Because people die when they get old. So if there's a lot of old people, the death rate is going to be high. When you see high crude death rates in countries in sub-Saharan Africa, probably it's going to be more likely due to like infant mortality, child mortality, and maternal mortality rates. If you see high crude death rates in really developed countries, you're going to attribute that to higher life expectancies. So that is why crude death rate is not a good indicator for development, because in the least developed countries and in the most developed countries, you're going to see high crude death rate, right? So for example, there's a higher crude death rate in Denmark than there is in Cape Verde, right? So like, anyway, I think you get my point. Okay, the last couple of things that I want to discuss is the factors that influence fertility, mortality, and migration. So if we're looking at what causes population growth and decline, it's these three things, right? But now we're going to look at, well, what changes these three things? So what influences fertility, mortality, and migration? Okay, so first and foremost, development has a huge or plays a huge influence on, or is hugely influential in fertility, mortality, and migration. I mean, you guys probably can infer like why it's relevant to migration. People are moving into countries that have opportunities out of countries that don't. But also when you're thinking of levels of development, so that economic sectors is important, right? So in countries that are primarily agrarian or rural, you're going to see higher crude birth rates because children are a not just like let's have babies, but it's their hands to work the fields, right? So they're part of an economic, not just a family structure. And so in areas where you have like high levels of service, where kids tend to go to school instead of work, your fertility rates are going to be a lot lower. Infrastructures are the same thing. So like economic factors, that influence population growth or decline. Actually, I don't think I want to put that one on there. That's more like a let me fix this because I actually disagree with myself now that I'm doing the presentation. So let me just reload this. Hit present again. Sorry, you guys. I love when I make mistakes. Okay, so but what I will say is that economic factors determine access to many other factors as well. So like what I mean by that is you need money, right? You need a good job in order to access healthcare or education. And so when you are listening to me talk, be aware, and by the way, hopefully you're seeing how important speeds actually really is. But you should be seeing how these connect to one another as well and how they influence each other. So economic factors might indicate a family's ability to get an education because unlike here in the United States, Education in most countries, parents have to pay for it, right? And the reason why I have education bolded and italicized is because education really is the key. When girls get an education in particular, what ends up happening is that has all kinds of effects on population growth. So if you have a fast growing population, but you start educating your children, chances are your children, the girls, are going to continue working or continue going to school until they're done with school, and then they're going to work. So then you get some connection back to the economic factors as well. And if they go to work, women tend to put off having kids, so you see lower fertility rates. And so as education increases, particularly for girls, then fertility rates and population growth tends to decline. Social factors like access to healthcare, adequate nutrition, all of these impact life expectancy, and life expectancy influences like how long people live. And what's interesting about healthcare is that, when you're looking at healthcare, it seems like, oh yeah, okay, so healthcare means that people are living longer, and so you're going to have less kids, kind of, sort of, because those are some of the trends that happen in more developed countries. But here's the thing: when healthcare becomes widely available, it can have contradictory effects on population and the rate of natural increase. So, improved healthcare in less developed countries can decrease infant mortality and increase life expectancy, which leads to a population boom, actually. But at the same time, those same healthcare facilities might potentially offer services like contraception for women and family planning services, would then decrease fertility rates. So it's kind of complicated, this one, a little bit. You just have to think through what is being asked or discussed, and then draw some conclusions based on that. I think this GIF is so cute. I like watching it. Okay, cultural factors. Religion, for example, can influence how fast or slow population grows, because according to some religions, like contraception is not allowed. This is why you see high population growth in places like Utah compared to, I don't know, Illinois. There is a very good TED Talk on religion and population growth that is listed as one of those optional things that you guys can watch. There's also a TED Talk extra credit sheet. So for those of you that are maybe looking for a little extra credit or a little boost because maybe you didn't love your FRQ score, you can always do TED Talks. Now you can only do 5 per semester. I haven't really talked about that, but if you want to do some, there's actually every single video listed for those 3 days of this week are excellent opportunities for TED Talk that'll really enhance your understanding of this population stuff. So check it out. Little RBG nod on the screen right now. Let me just move my face out of the way so you guys can read the quote. But another interesting cultural factor that influences population growth is gender equality. I don't know if you guys are kind of feeling this right now, but like, women are really important when looking at all things population, for obvious reasons, because they are the ones who are sometimes making the choices, but sometimes not having a choice, particularly in countries that have restricted gender equality, where a woman still has to fight her way out of the idea that a place for a woman should only be a home, and the role of a woman should only be to have babies, which, believe it or not, is still happening in many places all over the world. And when that is the case, when women are marginalized, then you tend to see higher fertility rates, higher rates of natural increase, higher population growth, and so on and so forth. Yeah, I just love that quote. Okay, last one, so I can finish this up. It wasn't supposed to be a long one. There are political factors that can influence population growth and decline. And migration, actually, I think it's why I set up there. But there's a whole learning target on this that I'm going to talk about later. So I'm just going to say very quickly what's up on the screen. On the right-hand side of that image is a propaganda poster from Singapore in the 1970s, I think it was, when the population in Singapore was growing really fast. Well, it worked too well, and now Singapore's like, oh, they're not doing very well in terms of population growth. They're in a population decline, so now they're trying to encourage more baby making. So Political factors include like policies that encourage or discourage fertility or having babies. And then governments can also put into policies that encourage or discourage migration, as if you've been paying attention to anything that's happening in this country. It's been a hot topic for the last couple of years. Okay, you guys, that's it. That's all I have. And by the way, we're not going to like do any activity with this. So make sure that you kind of get it, and B, that you've read your AMSCO book and that you can define every single indicator that I have put on this slide, because I did not define them for you. Okay.